we touched on and explained that we don't have access to the population. So we make use, I'm saying we as researchers, even in education, there is a use of a representative of that population. So that is referred to as a sample. So the calculations can be based on a sample and can also be based on a population. It is possible to collect data from a population, for example, the whole school. If the whole school take part in a study, that's the population of that school. But if you select as a number of students at a school, that is a sample. But I'm going to explain where that is affected. And then we realize as we move forward and ahead in the other term, we'll be focusing more on generalization or generalizing the findings um, to the whole population. But anyway, I just want to focus on the calculations. Um, so I tried to have very small um, values for explanation purposes. But in most cases, we have a lot of, let's say you collect data on satisfaction or maybe the level of self-esteem or self-efficacy among students. And then maybe usually the questionnaire or the scale is out of something. Let's say a quiz score out of 5, and then you collect a quiz just to test something at a school, and then the data, the marks that we've obtained is the data. Let us just assume that we collected, making use of a quiz out of 5, and then these are the scores that we've obtained from the students. So 1 out of 5, 2 out of 5, the other one out of 5, the other one 3 out of 5. And we can have a bigger kind of set of data, like 1,000, 10,000. There are people who deal with big data. I do that as well in my field. But just this to explain how we make use of such. So it is not easy to get a sense of what this data mean. So in research and statistics, and mostly we try to organize this kind of data. What does it mean? And then so that even someone who is going to read that data outside of ourselves will make sense of it. So that process is whereby we make use of a frequency distribution. I think you know the tally kind of, I think I was in grade 3, 4, I'm not sure, but it's almost the same. But now there's different ways of constructing um, that simple frequency distribution table. But the most common one is whereby in the textbooks that you read, I'm trying to see where's my case. So you see, I have a slide, a clean slide to show you how to do that. So you see that there is a table like this, whereby this X is the value of the data, like this 1, 2, 1, 3. Those are the X values. And then you see that there's an F, like the frequency, how many times is that value appearing in the data set. So I'm saying there are two ways in that. You can start with the lowest value and end um, with the highest value in the distribution. So you can start like the highest is 5, 4, 3, 2, and 1. So we are going to identify how many scores of 1 do we have in this data set. Okay. So we have 1, 2, 3. So we have 3 of them. And then how many scores of 2 do we have? We have 1. How many scores of 3 do we have? We have 2. How many 4s do we have? We don't have n, so it's a 0. So this is the frequency, the number of times that score is appearing. How many scores of 5 do we have? We have 1 as well. Okay. And then from this frequency distribution, you are able to construct a histogram. So histogram is used often because it informs us if the data is normally distributed. That bell shape, kind of bell curve shape, that is the intention. But we're going to explain the meaning and why researchers are interested in that bell shape kind of a histogram. So histogram is based mainly on like this is the frequency. Okay, I think I will this like 1, 2, um, sorry, 3. Excuse my writing. I'm left-handed. I'm using my right hand to move the cursor. I think this is the highest. Let me just write 5 just for control. And then the scores that we have. Let's start at 1, um, 2, 3, 4, and 5. And then how many scores of 1 do we have? So when you construct these histograms, you construct like from the center like this. Actually, that is standard. You can read around. It speaks to the real limits. Like in actual sense, these are rounded off scores in terms of the scores that are measured at a continuous level. But in our case, it's fine. But this is standard how we construct a histogram. And then how many scores of 2 do we have? We have 1. And then how many scores of 3 do we have? We have 2. Excuse my writing again. It's supposed to be straight. And we don't have a 4, but we have a 1, 5. So this is a histogram. Like people always want to draw some lines just to show some differences. But anyway, so this is a histogram. And it should be when the data is normally distributed, we have a lot of bars that are higher at the center, so that if it happens that we want to draw a line to connect the bars, it should come up with something that is almost a normally like a bell shape. So, but anyways, ignore that for now. But for now, I wanted to explain to you how to construct um, a simple frequency distribution. Okay. And also, we are able to identify how many, if we are given a frequency distribution like this, without these, it's rare that you get scores like this, but you are given this. So the question asked is, how many participants are in this study? If you are given a frequency distribution like this, so you are able to tell by adding the frequency. So the n, for in that case, if you read the textbook, the n is the sample size. So it's the sum of f. So that is n. So it means 1 plus 0 plus 2 plus 1 plus 3, of which is 7, is it? So without, you do that without even not being given these values as they were. I did that just to show you how to do it. I think and hope that makes sense. And then also, because of the other formulas associated with the descriptive statistics, you are able to calculate the sum of x squared. I'm going to do that for you with you now. And then we are also able to do the calculation of sum of x squared. Um, very important in the calculation of variability. And then also the sum of x, we can be asked to obtain and identify the sum of x. So the sum of x is not 4 plus 5 plus 4 plus 3 plus 2 plus 1. It's not. It's actually, you can multiply x times f for the first row, and then multiply for the second row, third row, fourth row, and fifth row, meaning that we need the multiplication of f and x, and then we add those two. Or you can break it down. So you identify how many scores of 5 do we have, and then you write it aside. And then how many scores of 4 do we have, we don't have. And how many scores of 3 do we have, and then you write 3 and 3. How many scores of 2 do we have? We have 1 and 2. And then how many scores of 1 do we have? And we have 3 of them. And then we can add. So that is the sum of x. But what I'm doing with, where's my, I can't see, okay, here. What I'm doing here is just show you can also do 5 times 1, that's 5. 4 times 0, that's 0. And 3 times 2, that's 6. And then 2 times 1, that's 2. And then 1 times 3, that's 3. So if we add this, So that is the sum of x. I think it's 16, 11, 12, 13, 14, 15, 16. So the sum of x is 16. And we use that when we do the calculation of the mean. I'm going to show you the mean is the sum of the scores divided by n. So it is important to understand this slide that you see now. Very important. Okay, I think it's fine. So now, um, in the assessments or in whatever that you want to understand at work, you are given, like I did, this the clean one. Mine is a little bit ugly. I did this. So this is almost a clean one. And then we are given these, for example, in assessment, we ask you to calculate the mean. We ask you to identify the mode. We ask you to identify the median. We ask you to calculate the range. We ask you to calculate the sample variance. Sometimes the population, there's a difference. I'm going to show you the difference in terms of the formula when you calculate the sample variance and the standard deviation variance, and also when you calculate the variance for the population, and then also the variance for population, standard deviation for the population. There's a slight difference. So now the mean for this, given this with what I have just explained in the previous minutes, it means that we need the formula for the mean is what am I write? I want to write this. So let me write m. The mean is sum of x divided by n. Okay. So now we know because we've done it, and we are able to check how many, what is the value of n, and if which I told you that n is actually the sum of f. So it's 1 plus 2 plus 1 plus 3, that's 7. So we have that. We know that. We do it like here. But now, what about the sum of x? And I've just told you and showed you that we multiply the rows like 5 times 1, 4 times 0, 3 times 2, of which is 16. Yeah. So the mean, we round off to 2 decimal places. So it's 16 divided by 7. So that is the mean um, for this. I wrote down now here, that's 2.29. If I'm mistaken, excuse if I made a mistake like this. So that is the mean score. And um, now we need to identify the mode. So the mode is the number that is appearing most. So you check which one is the highest number in the frequency. So the mode is 1. So the mode is 1. 1 appeared a lot of times more than the rest of the numbers. Okay. And then the standard deviation. So that is the mode. And then the median. We arrange all the scores in ascending or descending order. So it means we can write 1, 1, 1, 2, 3, 3. We don't have a 4, and we have a 5. So the median is the number that is in the middle of the scores. So these are kind of an odd number value. So this is the median. If we have, let's say we had a 5 here, so it means we have two numbers that are in the middle. So you identify the values, and then you add 2 plus 3 and divide by 2. So the median will be 2.5. So that is the median. And then the range is actually the maximum value minus the minimum value in a distribution. So the maximum value is 5, the highest value, and then the lowest is 1. So the answer is 4. So the kind of central tendency is self-explanatory and then quite simple sometimes and often. And then now we go to the variance. So there is a formula. We use the computational method. So the formula for variance for a sample is SS minus n, sum of squared deviations divided by n minus 1. But for a population, is it population? I don't know how you pronounce it, but anyway, divide by n. So n is the number of scores in a distribution. Remember I said so. So, but for our question here, we are say for a sample. So we are using this one. And then the formula for the easiest, the one that I use, see in the textbook for sum of squared deviations is sum of squared scores minus sum of scores squared uh, divide by n. So this, it means we square each score and then add the squared values. So it means 1 squared, 1 squared, 1 squared, 1 squared plus 1 squared plus 1 squared plus 2 squared plus 3 squared plus 3 squared plus 5 squared. Remember, this is not our part of we just added, I just added this to explain. So it means 1 plus 1 plus 1 plus 1 plus 4 plus 9 plus 9 plus 25. So it means 50. Minus sum of x, we have that. If we add all the values, is 16. And then we square that and divide by the number of scores that are in a distribution, of which is 7. Use my writing here, to apologize. And then if you do that, the squared, 16 squared divided by 7, you get 36.67. So 50 minus 36.57. So the sum of squared deviation is 13.43. 13.4. So we are almost there. Remember, this is the formula for variance. And actually, for standard deviation is this one in a square root. I'm going to show it's quite simple. And where is my okay here? So now we know that our SS is 13.43, and then divide by n minus 7. So it's divided by 7, n minus 1, sorry. Divide 7 minus 1. So it means 13.43 divided by 6. Let me check what's that. 13.43 divided by 6. So I'm getting, we round out to 2 decimal places. So the answer is, where's the answer? So the answer is, what is that? 13.2, 2.24. 2.24. 2.24. four, 2.24. Yeah. So that is actually the variance for this distribution. And then the easier part, the standard deviation is the square root of variance. So that answer that we have, for the standard deviation for this one. So it means, I can see my case. Where is it? I can see 2. Okay, I got it. Okay. So it means standard deviation is the square root of the variance that we've obtained. So a square root of 2.24. So 2.24, and I'm using the calculator, and then some calculators you punch in the square root first, and then some of them afterwards. So it's 1.50. So the answer is 1.50. So that is the standard deviation. If the answer was saying the question was calculate the variance for a population, we're going to say 13.43 divide by 7, not by 6. Remember, for a sample, we said divide by 6. So we're going to divide by 7 for a population. Okay, I think so. That's that. That is the descriptive statistics. So please, when you read the questions that we give to you, please check if for a sample or if the question is for a population. Okay, I think um, that is almost standard. Um, and then and then now I showed you the simple frequency distribution and associated calculations. But also sometimes we have, let's say we want to organize the data from an assessment. We give an assessment, but we want to check where are the highest scores, well, like how is the class performing, something like that. So we have larger values and that have bigger spaces. So it's not possible to summarize and organize if you want to make use of a simple distribution. What I'm saying is that it doesn't make sense to like this, like I just have these scores. We want to organize them in a way that is we can understand and see quickly and make a maybe decision. So when that happens, you cannot make use of a simple frequency distribution, because if you want to construct a simple frequency distribution, it end up being like this. It's going to be like very long, maybe until I don't know where, because you want to make use and include all the scores that we have. So let's say we start from the highest value is 52. Let's say start from 52. It means you need 52, 51, going down like that until you reach 13. So in that instance, in that case, you make use of a grouped frequency distribution where you have an interval and the frequency. So the interval, so we have this frequency here, and then you have interval, like I want to group the scores from a certain number to a certain number. But there is a way of doing it though. Like which value do you start with? Like you do accordingly. There's no kind of a blueprint in terms of which interval width do you use, but so long you summarize and organize the data. But the challenge with the group frequency is that we don't get a sense of like how many, like are the scores very close to 50? Are they close to 40? We don't know that. So that is the problem with the group frequency. But anyway, so the kind of what you should do as you plan to, where should you start? I'm going to try to change the color even. Let me change this color. Let me take green. I can't see, where's the, okay, here. So now we want to have intervals. Yeah. So you should start with the bottom low score in an interval should be a multiple of the width. Okay. So the width, if we are using a width of 10, so it means that the low score 10 should get into that number without leaving a remainder. So given that the low is 13, we should start at 10, not at 11. So 10 to 19, that is the width of 10. And then the second one will be 20 to 29. And then 30 to 39. And then 40 to 49. And then 50 to 59. Let's end here because our high score is 52. Okay. And then now we identify how many scores do we have that are between 10 and 19. I think I wrote, and if I'm sorry, excuse me, for the sake of time, I wrote down how many do we have. Where is my case? I can't see it. It's here now. If you can check, you have 6 of them. I'm not sure if I didn't make it. Maybe I made a mistake. And if you check how many are between 20 and 29, we have 8. It's like a tally, like we check. I mean, like we have 1 for the first one. 1, 2, 3, 4, 5, 6. So that's how it goes, the 6. And then 8. And then the other one is 4. Where's my The other one is 4. The other one is 4. And the last one is 2. And from there as well, you are able to construct a histogram of, of the using the group frequency. So you write here 10 to 19. Sorry, 10 to 19. And then 20 to 29 in the same manner that we did with the others. And then also here is the frequency, like how many scores that I between that 1, 2, 3, until whatever that we have. So until maybe it's 8 or 10, depending. So for the first one, we have 6. So if 6 is here, so you construct that histogram like this. And we don't have gaps with between the bars of histogram, no gaps because of the real limit issue. And then that is how you construct that graph in the same way, man. I'm just sketching, not true scores though. So that's that. That is the frequency distribution, the simple one, the grouped one, and the central tendency and the variability. So what you should know now, which is a little bit easier, we have z-scores and we have probability. So if you know those, at least we are covered in terms of descriptive statistics. So yeah, this is what I was trying to say. We don't have gaps between the bars because of real limits. Actually, sometimes and often in actual measurements outside of the quiz and others, the values can be rounded off. Usually they are rounded off. So it's actually we are giving leeway to say, but a 20 can be a representative of 19, any value between 19.5 and 20.5. That is why it is like that. So thank you so much. Enjoy that. These are the formulas if you want to see them in a quiet and